Hello everyone. Today we are going to understand glycolysis, which is a common pathway for aerobic and anaerobic respiration. Now, first let's try understanding what is glycolysis. Glycolysis is the first pathway used in the breakdown of glucose to obtain energy. Now, I want you to focus on this particular point, breakdown of glucose to obtain energy. Always remember, whenever you are breaking down glucose and you are receiving energy from that reaction, it is a primary reaction of respiration. That's why glycolysis comes under respiration. Okay, it's the first pathway of respiration. Next point that we have over here, glycolysis is also called as Embeden-Meyerhof pathway. We also call it as EMP pathway. That's the simultaneous name. The entire process occurs without molecular oxygen. So this itself should give you an idea that glycolysis is not occurring in mitochondria. Okay, so glycolysis does not require molecular oxygen, meaning whether it's an aerobic organism or anaerobic organism, this process can easily take place. Last point is glycolysis consumes 2 ATP and generates 4 ATP. So basically it is meant for generation of 2 net ATP. Let's try to go through it. Breakdown of glucose to obtain energy. So how much energy are we getting? 2 net ATP. Adenosine triphosphate. Always remember ATP is the energy currency of the cell. So definitely we are bound to get some ATP molecules, right? Now, whether it's a eukaryotic organism or a prokaryotic organism, in both of them, glycolysis is going to occur. Whether it's an aerobic organism or an anaerobic organism, glycolysis is meant to occur. And the primary site of glycolysis is cytoplasm. So whether we are talking of eukaryotes or we are talking of prokaryotes, both the places our glycolysis will occur. Remember, it's the first pathway, not the end pathway. So after glycolysis, depending on which organism we have, which type of cell we have, the pathways differ. Okay. Now, glycolysis itself is not a one-step pathway. It's basically a 10-step pathway. And glyco means glucose, right? Lysis is breakdown. This breakdown of glucose to obtain energy occurs in 10 steps and is divided into 2 major sections. We call them as first phase and second phase. First phase is called as your preparatory phase, where you're going to prepare your glucose molecule for breakdown. So first step is preparatory phase. And the second section is called as payoff phase, where you're going to generate ATP out of glucose. So this is payoff phase. Okay. Out of the reactions that are going to happen, preparatory phase basically focuses on conversion of glucose to a molecule called as glyceraldehyde 3-phosphate. Okay, which we are going to see in our reaction. And payoff phase basically is conversion of glyceraldehyde 3-phosphate to particularly pyruvic acid or pyruvate. Okay. So technically, while we are converting glucose to glyceraldehyde 3-phosphate, we would be consuming some energy, consuming some ATP. Okay, and in the payoff phase, while we are converting glyceraldehyde 3-phosphate to pyruvic acid, we would be receiving some energy. Okay, the net energy generally is going to be 2 ATP, which we'll be looking for. In this particular video, I'm going to discuss glycolysis step by step using the structures. I feel personally the structures play an important role in understanding whether ATP is utilized, released, hydrolysis is happening, hydration is happening, what is basically the condition. Okay, and at the end, I'll help you revise and recollect all the steps together. So let's start with the first phase, that is preparatory phase. And this preparatory phase has step number 1. Step number 1 is going to be glucose being converted to a compound. So we all know how glucose looks like, okay? So here we have our glucose, okay? It's basically 1, 2, 3, 4, 5, 6, 6 carbon ring compound, okay? And this glucose is being converted to, you can see again a 6 carbon ring compound, but there is a phosphate. So basically this is glucose 6-phosphate. Why 6-phosphate? Because phosphate group is attaching on the 6th carbon. 1, 2, 3, 4, 5, 6. Okay, so on the 6th carbon, we have a phosphate group attached. Step number 1, glucose gets converted to glucose 6-phosphate. Can you see there is an addition of phosphate over here? So whenever you're adding a phosphate, what you need to do? ATP gets utilized. ATP is what? Adenosine triphosphate, meaning there are 3 phosphate molecules, right? And it gets converted. 1 phosphate gets utilized in making glucose 6-phosphate. So now you're going to get ADP, adenosine diphosphate. So triphosphate to now diphosphate. Okay. So this one phosphate is basically coming over here. This is happening in the presence of something called as glucokinase or an enzyme called as hexokinase. You need to remember the enzymes. You can find n number of mnemonics on Google. You can definitely go for it. Okay. So what have we done? Step number 1, glucose got converted to glucose 6-phosphate in the presence of an enzyme called hexokinase. And because 1 phosphate group is added to the molecule, ATP got utilized. This happens in the presence of a cofactor, that is magnesium ion. Okay. Let's go on to the next step. Step number 1 has yielded us glucose 6-phosphate. So let's see what does step number 2 give us. Okay, in step number 2, this particular glucose 6-phosphate gets converted into fructose 6-phosphate. Now, those who know carbohydrate structures might actually understand that glucose as well as fructose come under monosaccharides. And another thing that you can see over here, 1, 2, 3, 4, 5, 6. Even fructose is a 6 carbon 5-member ring compound. So forget about 5-member ring. Remember one thing, that both glucose as well as fructose are 6 carbon compounds. So technically not much difference has been made. So glucose and fructose are nothing but isomers of each other. Okay. Have we lost any ATP? No. Have we added much of phosphates? No. So there is no change over here, only an interconversion, or we can say an isomerization. So the enzyme used over here would be isomerase. Okay, both are isomers of each other. That's why we are using isomerase. The name is a bit different. It is phosphofructoisomerase. Okay, phosphofructoisomerase. Best part, because it's an isomer, this is a reversible reaction. Okay, many a times in examinations like NEET, CT, okay, where they ask which of the following are reversible reactions, there it might be important to know. So see over here, because these are isomers of each other, they can be reversed. Okay. Now we have got what? We have got fructose 6-phosphate. Up till now, we are discussing about compounds which are all 6 carbon compounds. Okay. Step number 3, we are going to consider the fructose 6-phosphate. Fructose 6-phosphate. And what is happening over here? we are converting it to, can you see there are two phosphate groups? One on the first carbon, another one on the sixth carbon. So we are converting fructose 6-phosphate to fructose 1,6 di or biphosphate. Now over here bisphosphate is also a term. So accordingly you can go ahead and name it, no problem. Bis, di or 2, meaning two phosphates are being attached to the same molecule. Okay. Now look over here carefully. What has been done? We have added a phosphate, right? We have added a phosphate on the first carbon. So from where did that phosphate group come from? It came from ATP. ATP has how many phosphates with them? 3 phosphates. One phosphate got utilized in making the compound. So now we are left with ADP. Again, this reaction has got a cofactor, that is magnesium ion. Sometimes even manganese ion can be used. And because over here a phosphate group has been added, we call it as phosphofructokinase, PFK. Very important step. It is also called as a rate determining step. It's irreversible, you can see, because ATP has been utilized to completely change the compound. We cannot reverse back this compound. So it's an irreversible rate limiting step of our reaction. We have discussed 3 steps. From glucose, we went to glucose 6-phosphate, to fructose 6-phosphate, to fructose 1,6 bi or bisphosphate. Okay. Now, step number 3, that after step number 3, we have got step number 4. In step number 4, what is happening? Let's see. Our fructose bisphosphate, fructose 1,6 bisphosphate is getting converted. But rather than saying converted, we can say it is getting broken down into 2 compounds. So our fructose bisphosphate is getting broken down into 2 compounds. Which are these compounds? Let's try to understand. First one, because you can see over here group, there is an aldehydic group over here. So this is nothing but glyceraldehyde. Glyceraldehyde. 1, 2, 3. 3-phosphate. So the first compound, fructose 6,1,6-phosphate, is broken down into is glyceraldehyde 3-phosphate. And the other is what it is, you can see over here, it's a ketonic group. So this is nothing but, sorry, my bad. It is dihydroxy acetone phosphate. Okay. So our fructose 1,6 bisphosphate gets broken down into glyceraldehyde 3-phosphate and dihydroxyacetone phosphate, that is DHAP. Okay. So which enzyme gets utilized over here? Let's try to understand. The enzyme is going to be aldolase. Aldolase, lase itself means breaking down enzyme. Aldolase is a lyase. Lyase meaning it is a breaking down enzyme. So whenever this enzyme is used, your compound is bound to undergo breakdown. How is this breakdown happening? If you want to see, it happens like this. Okay, so this separates out as one particular compound and the rest part separates out as other compound. Okay, now this is how we are reaching to glyceraldehyde 3-phosphate. Okay, here technically as soon as glyceraldehyde 3-phosphate is generated, what do we say? We say that our preparatory phase has got over. Now we start or we enter from step number 5 onwards, we enter the payoff phase. Meaning whatever investment we had to do into making these compounds, that's done. Now we are going to only reap out the benefits. Okay. So I hope you all have understood the preparatory phase. Preparatory phase has got us into the conversions of glucose 6-phosphate, glucose phosphate to glucose 6-phosphate, glucose 6-phosphate to fructose 6-phosphate, fructose 1,6-bisphosphate to glyceraldehyde 3-phosphate and DHAP. Here we stop. Now, if you see glyceraldehyde 3-phosphate and DHAP both are isomers of each other. The compounds are isomers. The next phase we are going to discuss is going to be payoff phase. Okay. Okay. So let's start our payoff phase. Okay. This step number 5 is basically a transition step. We are moving from preparatory to our payoff. What did we get? We had got glyceraldehyde 3-phosphate and DHAP, right? Now, I told you something. I told you both of them are isomers of each other. So what would happen? They both will undergo isomerization to yield one common compound. DHAP will isomerize itself to give glyceraldehyde 3-phosphate itself. Because both of them are isomers of each other, both of them will result into forming glyceraldehyde. DHAP gets converted into glyceraldehyde. Okay. So what do we get? We get 2 molecules of glyceraldehyde 3-phosphate. Which enzyme are we talking about? We just saw isomerization, right? So we would be utilizing isomerase enzyme. What is the name of this isomerase? This isomerase is triose phosphate isomerase. Okay, so both glyceraldehyde 3-phosphate DHAP, they take on to become glyceraldehyde 3-phosphate. So now we have 2 molecules of glyceraldehyde 3-phosphate with us. Let's see step number 6. Now we have well entered into payoff phase. Now we'll start getting back our investment. Okay. So see, we have glyceraldehyde 3-phosphate. I'm writing this along with you so that you don't feel like it's one monotonous presentation. Okay. And this glyceraldehyde 3-phosphate gets converted into a different compound. See over here, how many phosphates do we have? We have 2 phosphates. Okay. 2 phosphates meaning bisphospho. And now, rather than being glyceraldehyde, it has become glycerate. See, glycerate. Okay, it's turning into an acid. So, bisphosphoglycerate. Bisphosphoglycerate. From aldehyde, it has converted, it has oxidized into what? A carboxylic acid. How many phosphates do we have? We have 2 phosphates, one on the first carbon and another one on the third carbon. That's why this step is also called as oxidative phosphorylation. Now see the term. We have 2 phosphates over here, meaning 1 phosphate has been added. So what do? 1 phosphate has been added. Now one might say, okay ma'am, ATP investments were almost done. Now what to do? Here, rather than using ATP phosphate, we are going to use an inorganic phosphate. So rather than using ATP, we are going to use an inorganic phosphate. And most of the time, it is from a compound called as H3PO4. Okay. Remember, there were 2 glyceraldehyde 3-phosphate. So definitely 2,1,3 bisphosphoglycerate would be formed. So we would be requiring 2 inorganic phosphates. Along with this, we have a coenzyme called as NAD+. This coenzyme is getting converted to NADH plus H plus. In the presence of the cofactor, again, same Mg2 plus, and along with Mg2 plus, we have Zn2 plus. Okay, Zn2 plus is very specific for nicotinamide adenine dinucleotide. Okay, so see what was happening. We have 2 glyceraldehyde 3-phosphate being converting, so everything is taken into twice the amount. Okay, the phosphate that we are utilizing is not ATP phosphate. That's why it is not coming under preparatory phase. Okay, we are using an inorganic phosphate which is generally taken up during the reaction. What did we get? We got oxidative phosphorylation done, and now our aldehyde has converted into a glycerate. Let's go on to the next step. Next step is the 7th step of the reaction. In step number 7, we have a previous compound, that is 1,3 bis phosphoglycerate. 1,3 bis phosphoglycerate, and this is getting converted to, pay attention over here what is happening. We have only one phosphate over here now, right? Meaning one phosphate has been released. Okay. And what is this left? Our acidic formation, right? So only the 3rd carbon now has phosphate with it. So we are left with 3-phosphoglycerate. The one phosphate which has been released, it is picked up by ADP, adenosine dinucleotide, right? Sorry, it is adenosine diphosphate. Okay, so one phosphate which is released is being picked up by ADP. And now this ADP, because of that particular phosphate which is picked up from the molecule, gets converted to ATP. Okay, so ADP gets converted to ATP. What do we need to remember over here? That the 3rd phosphate has been utilized from here. So one phosphate has been picked up. What is the next important thing? Because 2 molecules are being utilized over here and converted, even 2 ADP gets converted to 2 ATP. So what is the net gain? 2 ATP over here. Okay. Whenever we talk about ATP, one important cofactor, magnesium. Whenever we talk about NAD, there is zinc. Okay. So see, our return on investment has already started. Okay. Now what is next? Next is step number 8. What is happening in step number 8? In step number 8, the previously formed compound 3-phosphoglycerate gets converted to another important compound. See over here, the phosphate group has moved from the 3rd position. See, this was 1, 2, 3. From the 3rd position, our phosphate group has moved to the 2nd position. So now we have 2-phosphoglycerate. Okay, what has happened? Nothing extraordinary has happened over here. Only the movement of phosphate group from one carbon to another carbon. So under such condition, it is irreversible. And the enzyme that we would be using for this would be phosphoglycerate mutase. Mutase indicates that there is no specific change which has happened. Only one particular part of the compound has moved to the other part. So phosphate has moved from 3rd carbon to 2nd carbon. Okay. Now we are going on to the second last step. Again, the same thing is needed to be understood, 2 molecules each. Okay. Step number 9, second last step of our reaction of glycolysis. Step number 9 would be what? We previously had got what? 2-phosphoglycerate. Phosphoglycerate. Now this 2-phosphoglycerate now gets converted. Pay attention on what is happening. Okay. One hydrogen from here and OH from here they combine and leave as water molecule. They combine and leave as water molecule. Okay. So now we are left with a compound that is phosphoenol pyruvate. Enol means what? A compound having ketone as well as a double bonded carbon. Okay, so it has a carboxyl carbon. See over here. Weight meaning there is a acidic group, that is C double bond O minus. You can see over here. Enol means what? There is another double bonded carbon group. Okay, so now we have converted from phosphoglycerate to phosphoenol pyruvate. And why did this conversion happen? Because one water molecule was released. Now see, 2 phosphoglycerate got converted to 2 phosphoenol pyruvate, right? So how many water molecules are released? 2 water molecules are released. Okay, and the formation requires an enzyme called as enolase, a enzyme which is going to promote the formation of enol group or double bonded carbon group. This takes us to the last step of the glycolysis, that is step number 10 or the final step of payoff, where we have phosphoenol pyruvate, sometimes we also call it PEPA, phosphoenol pyruvate to pyruvic acid or pyruvate. Now, why do we call it pyruvate and not pyruvic acid? Whenever our acid is not completely terminating as COOH, rather it is COO minus, we call this thing to be 8. So if suppose there was COOH, it would have become pyruvic acid. Technically, we consider it to be pyruvic acid, but the structure represents a little bit of difference. What is happening over here? Let's try to understand. We lost a phosphate group, right? So whenever a phosphate group is lost, what is the primary thing? Primary thing is ADP, meaning 2-phosphate group got converted to ATP. So this third phosphate came from the PEPA. Okay. And whenever ADP conversion or ATP conversion is there, we require magnesium ions. And the final thing that we need to know over here is pyruvate kinase. That is the enzyme that is being utilized. Another thing, 2-phosphoenol pyruvate got converted to 2-pyruvic acid or pyruvates. So definitely 2-ADP got converted to 2-ATP. And that is how the complete breakdown of glucose has resulted into a 3-carbon compound called as pyruvate. Let's try to revise this completely now. We started with glucose. Glucose got converted to glucose 6-phosphate. Glucose 6-phosphate got interconverted to fructose 6-phosphate. There was an addition of phosphate group, so it became fructose 1,6 diphosphate. Okay, this fructose 1,6 diphosphate became glyceraldehyde 3-phosphate and dihydroxyacetone DHAP phosphate. Both of them are isomers of each other. So we got 2 molecules of glyceraldehyde 3-phosphate. Okay. And we entered with this to our payoff phase. In the payoff phase, the 2 molecules of glyceraldehyde 3-phosphate, they converted into 2 molecules of 1,3 bisphosphoglycerate or bisphosphoglyceric acid. Okay. Then there was a removal of phosphate group and we were left with 3-phosphoglycerate. there was a mutase enzyme resulting into 2-phosphoglycerate. From 2-phosphoglycerate, now we have completely utilized our glycerate. We are going into the acidic parameter. We got 2-phosphoenol pyruvate. And finally, we got 2-pyruvate. Let's try to quickly break this down. We started with a 6-carbon compound glucose and we terminated with 2 molecules of 3-carbon compound called as pyruvate or pyruvic acid. Okay, where all did our ATP get invested? Our ATP investments came over here. So here we utilized ATP. Here we utilized ATP in adding the phosphate, right? And over here, we released out 2 ATP. And in the last step, we released out 2 ATP. So we utilized 2 ATP and we released, or the return on investment was 4 ATP. So net would be what? Net would be 4 minus 2. That is 2 ATP. That was a profit. Okay, so 2 ATP was the profit of glycolysis. I hope you have understood this particular section. Until we meet next, signing off. Bye.